Welcome to the viewers. Now we discuss locally connected space. At first we are starting with the definition. Let us consider, let X tau be a topological space which is called locally connected at any point, say arbitrary, if we say at X belongs to capital X, if every NBD of X contains a open connected NBD of X. It is our criteria and definitions. Now we have to clear this idea that in these topological spaces, that every NBD of X at any point, if we consider in the arbitrary space, any point in the spaces X, if we consider, then we find every NBD of X that contains a open connected NBD of X. Say, let us consider the space as for example to clear the idea. If X be the arbitrary space given by, say, 0 1 union 2 3 in this way as a topological space, with usual topology, and if we consider any member, say this arbitrary space, and if we say in these spaces, in this region like this, for 0 1 and it is 2 and 3 in this way, and if we consider any arbitrary space of real number and whole entire space that will be given by these two, this and this, these two region is engulfed by the entire space, covered up. That is, we are taking the union of these two regions, particularly these two, and excluding these two, 1 and 2. And if we plot any kind of a number between 1 and 2, that is, say, alpha, whatever may be the region is alpha, if it should be noted that taking the number of alpha, then alpha must be belonging to open interval 1 and 2, and this arbitrary space, if we consider this arbitrary space, then this alpha region, and that must be minus infinity to alpha, and that is a common intersections of this region of this space, that is these spaces, and union of that spaces, that is minus infinity to alpha. If we consider intersection this arbitrary space X, that is only this part, and taking the union of alpha to infinity intersection X, and this is a disconnection.
কাগজ
for x. This is a disconnection for s. It is clear that this point is outside of these points of spaces. So this is a disconnection. And if any element like whatever may be the like element of b, if it belonging to x, and say this b is belonging to 0 1, if we take in between the point like v, just simply taking in these areas, then we can find it like a delta region. And if we say arbitrarily, and if we say this region of V in 0 and 1, and we find it another region like the neighborhood region, if we say it V plus delta and V minus delta, then where delta greater than 0, then we find we have this region V minus delta and V plus delta, that must be NV. And as an open interval of reals is connected, if we say, and this is locally connected, because there is some disconnection, but this is a locally connection that depends upon the type of delta, what the delta is. We find different type of connection is there, that's why they are locally connected. If we say the value of the delta deteriorated, we find there are the many intervals, such type of interval, that is the NBD points. So many points are there. And if we consider U as belonging to the region 2 and 3, in this way, we are going to the earlier situation. Just a moment. If we say this like U is there only between 2 and 3, what happens there? We have to show this. And if we say this between 2 and 3, similarly U, so here also U plus delta and here U minus delta. So here also we find the region like this. We have this U minus delta and U plus delta, that will included in the region of NU and delta greater than 0. So NU contains an open interval, that is contain an open, better to say connected NBD of U, which is also locally connected at U. So X is locally connected at U, and in the earlier situations it is locally connected at V, that is called NV. This is locally connected at V. So X is locally connected at V, and here X is locally connected at U. So in this way we see there are the two regions where in this situation 0 1 where x is locally connected of the whole situations at V and x is locally connected at U. So here also we prove that x is locally connected. Both U and another connection is there. If we say here also x is locally connected at V, U and V, and here is the disconnection. So in this way we get some of the concept about locally connections. We already proved these results in these two intervals, and here is the disconnections. Now in this way we throw some ideas about the locally connected spaces. We end our discussion today. If you like this video, like it, share it. Don't forget to subscribe the channel. Thanks for watching.